Okay, in this unit, we're going to be talking about logarithms. Logarithms are the inverse of exponents. For example, we're asked to evaluate these expressions, and it says there should be no calculator needed. There is a way to do these on your calculator. However, they kind of want you to analyze the logs and find the answer that way. So when you look at this log, we say this log base 4, this small number down here is your base, of 64. And what that is asking is what power of 4 to what power equals 64. Okay, so some of these we can do by knowing the powers. Some people like to do it by trial and error. They'll take your calculator and go, okay, 4 to the first power is 4, 4 to the second power is 16, 4 to the third power is 64. The answer to this question is 3, because 4 to the third power is 64. Log base 4 of 64 is 3. This next one, log base 5 of 625. So again, what we're asking is 5 to what power equals 625? Okay, so again, you might do that by trial and error, or you may know the powers of 5 really well. But you will find that 5 to the fourth power is 625. So the answer to this question is 4. Because again, 5 to the fourth power is 625. This is the expression written in logarithmic form over here in our question. This is the expression if we wrote it in exponential form. Log base 2 is 16. So again, they're asking 2 to what power is 16? Okay, so this is what we're trying to figure out. 2 to what power is 16? And it happens to be that 2 to the fourth power is 16. And our last one down here, log base 7 of 1. Log base anything of 1, it doesn't matter what your base is 0. Because the only way to get 1 is if you take something to the 0 power. Okay? Because 7 to the 0 power is 1. Hey, here are some more examples. These are getting a bit more complicated. We're just going to go gradually up as we do examples. This log base 3 of 1 over 27. So again, what we're asking is 3 to what power is 1/27. Now, anytime you have a fraction, that means that we have a negative exponent, because if you'll recall from exponents, negative exponents move the number down into the denominator of a fraction. So then what you want to ask is, well, how would I get 27? That's a good place to start. 3 to what power is 27? We know 3 to the third power is 27. So to get 1 over 27, we'd have to go 3 to the negative third power, because if you, just as a review, 3 to the negative third is 1 over 3 to the third power, which would give us 1 over 27. So the answer to this problem is -3, because 3 to the negative third power equals 27, or excuse me, 1/27. Okay, let's try the next problem. Log base 1/4 of 16. So again, what we're asking is 1/4 to what power equals 16? Well, notice we went from a fraction to a whole number, which again tells me I must have used negative exponents. Okay, so then we say, well, let's look at what we kind of our bases here. 4 and 16. How would I get 4 to equal 16? Well, it would be 4 squared. Okay, but if we try that, let's say we tried 2. Okay, 1/4 squared is 1/16. We don't want 1/16, we want 16. So what we would do is say, okay, well then it must have been a negative power. 1/4 to the -2, okay, remember, would invert our fraction, and that would give us 16. So our answer here, 1/4 to what power is 16? 1/4 to the -2 power is 16. These take a while to get used to. It takes a while to get used to manipulating the numbers and figuring them out. You can always check them on your calculator once you're done and go back and say, does that really work? All right, log base 2 of 1/16. So again, we're saying 2 to what power gives me 1/16. Since it's a fraction, I know I must have a negative exponent of some type to get me into a fraction. So then I'm going to say, well, how would I get 16? 2 to what power is 16? 2 to the 4th power is 16. 2 to the negative 4th power is 1 over 16, or 1 over 2 to the 4th. So our answer here is -4, because 2 to the negative 4th power is 1/16. Okay, here are a few more. We're just kind of getting more complex types of problems as we go. On this page, so again, we would try to start this the same way. 25 to what power is 125? But if you kind of investigate that on your calculator, you'll notice 25 to the 1st power is 25. And 25 squared jumps clear over 125. It's 625. So what that tells me is that I must have a fraction exponent in there. So what I want to try to do is write 25 maybe as a different number and then go from there. Okay? So let's look at 125. Is it a power of any number? Well, we know that 125 is the same as 5 to the 3rd. Okay. Well, can I write 25 as a power of 5? I can. It's 5 to the 1/2 power. Okay, so looking at this, what we could do is take the square root of 25 as 5. Okay, and then if we take that to the 3rd power, we'll get 125. So then what is our power? Is what we're going to ask. Well, what did we do to the 25 initially? We took the square root. And what does square root mean? That means the 1/2 power. So what we're doing is 25 to the 1/2 power. And then that gave us 5. And we took 5 to the 3rd power. So we're going to the 1/2 power and then to the 3rd power. Or we can write that as 25 to the 3/2 power. And you can go ahead and check that on your calculator. When you do that, make sure you put the 3/2 in parentheses. Okay, 25 to the 3/2. And if you check that, you will find that, yes, it is, in fact, 125. Okay, so our answer here is 3/2. 25 to the 3/2 power is 125. So if the numbers don't seem to match up quite right, you may have to use fractional exponents. You may have to take roots. Okay, log base 16 of 4. So this again is saying 16 to what power equals 4? Well, the square root of 16 is 4. And what does square root mean? Square root again means the 1/2 power. So 16 to the 1/2 power is 4. So log base 16 of 4 is 1/2. Okay. Log base 9 of 27. Okay, so again, 9 to what power equals 27? Well, 9 to the 1st power is 9, and 9 squared is 81, jumps right over the top of 27, which tells us that we're going to have to do like we did on the first one on this page and maybe look for a different exponent. Okay, well, let's see. 9 is a power of 3, and 27 is also a power of 3. So let's try to rewrite this. Okay, let's say 9 is 3 squared. Okay, so if we do the square root of 9, we would get 3. Let's write it down below. And if we take 3 to the third power, we get 27. Okay. This is going to give us 27. Again, because we do the square root of 9 is 3, and 3 to the third power is 27. So now let's write this as an exponent. 9 to what power is 27? Well, we did 9 to the 1/2 power. That's what square root is. And then we took that to the third. So 9 to the 3/2 power. So again, over here, we have the answer would be 3/2. 9 to the 3/2 is 27. Okay, so these are a little tougher. Take a little more mind power there. Okay, these look very complex, but with the basic properties of logarithms, they're not as bad as they seem. Okay, the basic properties of logarithms give us a couple of shortcuts, and that's what we're going to use here. I should have just pasted the page out of your book, but in your book, it does give you these properties, and I'll write it the way they have it in the book just to be consistent. Okay, log base b of b to the x is just x. Okay, so if you take log and the base, notice these are the same. Some people just cancel them out, okay? But log base b of b is 1, so then you just have that x left over. So this one, log base 70 of 70, basically you're asking 70 to what power is equal to 70 to the 185th power. So you can see that it's just 185. Okay, so that's one of the basic properties of logarithms. Okay, and again, this log base b of b to the x is just x. Okay, so here's another one. Let's write that as a fractional exponent. Okay, we have log base 12 of 12 to what power? This is 12 to the 12 squared, and then to the 1/5 power, or excuse me, 12 to the 2/5. Okay, this 5 out here with the root tells me that's 1/5, and the 2 here gets me squared. So I have log base 12 of 12 to the 2/5, which is just 2/5. And the last one down here, log base 8 of the square root of 8. Again, what we're doing here is log base 8 of 8 to the 1/2 power. It's important you remember that that's what square root means, is the 1/2 power. Gives me 1/2. And again, that's because you're basically saying, if you do log base 8 of 8 to the 1/2 power, you're basically saying 8 to what power is equal to 8 to the 1/2 power? Well, it's 8 to the 1/2 power, okay? All right, last one. You may notice that there are some that do not have bases listed, okay? If there's not a base given, we automatically assume it's base 10. And this is why if you do a problem on your calculator with the button, you'll see that you have a log button on your calculator, but that is automatically base 10. So you can't really do a problem just straight out log base 5. There is a way to do it on your calculator, but you can't just use the plain log button because the log is automatically programmed to do base 10. So again, anytime you see problems without a base listed, without that little number down there, it's automatically base 10. So this is asking 10 to what power is 0.001? Well, 0.001 is the same as 10 to the -3rd power. So you are doing log base 10 of 10 to the negative 3 is just negative 3. Here's another one, log base 10 of 1 over 10,000. And again, what this would be is, remember 10,000 is 10 to the 4th power. The fraction there tells us we're doing, that's the same as 10 to the negative 4th power. So we have log base 10 of 10 to the negative 4 is just negative 4. And here's our last one, log base 10 of the 7th root of 10 to the 11th. Again, to rewrite this, the 7 tells us we're doing the 1/7 power, and this tells us we're doing the 11th power. So we're doing 11/7. Okay, so we're doing log base 10 of 10 to the 11/7 is just 11/7. Okay.